In this video, I will talk about econometrics and economic data in R. Before you watch this video, please make sure that you have watched my other video called Econometrics and Economic Data. So the outline of this presentation would be to talk about cross-sectional data, time series data, pooled cross-sections, and panel or longitudinal data. The first thing I have done here is open up the R script that you see here. I have highlighted all of it and then I have executed the program. I have run the program and this is the console window that I have moved from the bottom here to the side so that here are all the results that we're going to be seeing from this program. So in order to get started, you need to download obviously the script and then the 4 data files, and you need to put them somewhere on the hard drive, and this is where my files are, and you need to change this directory to your directory on your computer. So with the first line here, we're actually clearing the workspace. If there's anything in the workspace, we would be removing it. And so we're going to start with a blank list. The next thing that we're going to be doing is installing the packages that we're going to be using for this R script. So here, we're going to be using 4 packages: Tidyverse, Stargazer, uh, migrator, and moments. And this is basically a loop here that would download the packages and checking if they're already installed, and if not, it's installing them or updating them. So you would just be running this code. So the next thing to do here is talk about cross-sectional data. So cross-sectional data is basically data set that is across individuals, but it does not have a time series dimension. So in this particular case, we have cross-sectional data on wages and other characteristics, and in particular, the observations are individuals. In other words, it's people. So how we're going to be using this data set is the data set is called wage1.csv file. And here we're going to be using read.csv because uh, this is a CSV data file. And here we're pasting basically the directory that we um, used above. So you can either use this command if you have already specified where the data is, or you could basically just put this directory in here and that's the equivalent for that without using this code here. So this is how we're going to load the data set and the data file wage1.csv, and we're going to be calling this data file now wage. So that would be the data that we're going to be using. Now let's summarize the data. We're going to be using the Stargazer for that. Here we first have to specify the data set, which is wage, and then type would be text. And so here is, if we execute this line here, we're going to be seeing all of the variables that we have in the data set. This is the number of the observations, mean, standard deviation, and so forth. And again, we're going to be seeing summary statistics for all of the variables in the data set. Now, suppose that we want to only see summary statistics for selected variables. So let's basically only select the variables wage, log wage, education, and so forth. And so we're going to be using the data set wage. So this wage is the same as this wage data set. This wage actually is the name of the variable here. So that's a bit confusing right here. But then we're going to be using Stargazer to do the summary statistics. So what you're going to see here is that we only summarize the data for the selected variables. This here is called the pipe operator, which forwards the left-hand side to the right-hand side. So what this is saying is that from the data wage, we're going to be selecting these variables, and then for that, we're going to be using Stargazer. So basically, this pipe operator forwards these as the first argument in these next functions. So here we have another pipe operator. So this is basically a more elegant way to write the code here. So these are the summary statistics that we have. We have a cross-sectional data here. Again, 526 observations. This is the mean value for the wage. This is the mean value for log wage, and so forth. So this is how summary statistics look like for cross-sectional data. So the next thing that we can do is we can only keep only selected variables in the data set. So in this case, we would be selecting these variables, and then we are going to be keeping only them in the data set. So basically, we're going to be reassigning these variables back the data set. Into the data set. So here, if we are then summarizing the data and structure, we are going to call the structure for this data set a wage. So again, this wage is the data frame that we have. In this data frame, we have these variables in there, and then you can see the first a few values in the data frame. Okay, so next thing we can use the Stargazer. Using the data frame wage, we can just summarize the data using type equals text. So these are again the summary statistics. So note that because we have only kept a few variables and here, and we have reassigned them back into the data frame, we actually do not need to specify which variables we're going to be summarizing in the Stargazers, because we are now summarizing all of the variables. Another useful thing is to use head. This is the data frame and the first 10 observations. And what this is showing us is basically the values for the first 10 observations in the data. So this is again how cross-sectional data looks like. We have the first 10 observations. Remember that these are the individuals in the data. And this is the wage for the first individual, the log wage for the first individual, and so forth. This is the number of years of education, number of years of experience, and so forth. This is the data for the second individual, for the third individual, and so forth. So again, we do not have time series dimension here. Everything is cross-sectional. We only have cross-sectional dimension. And the last thing to summarize here with cross-sectional data, we could be using a frequency table by using table. Here we're going to call the data frame wage, and of this wage, $ female, we're basically going to be selecting the female variable in the wage data frame, and we're going to be putting here in a summary table of frequencies. So here what we see is that we have 274 zeros and 252 ones. So these are the females in the data, and this is the number of males in the data. So anyway, this is very briefly how to summarize cross-sectional data. Now let's move to time series data. So with time series data, we only have time dimension of the data, but we do not have cross-sectional dimension of the data. So now we are going to be having the observations over the years or over months or days, but we would not have cross-sectional dimension, like we would not have different individuals, different countries, firms, and so forth. So for time series data, here we have data on minimum wages and related variables. So we're going to be loading the data set and keeping only selected variables. So here we're going to use read.csv, and this is going to be the CSV file that we're reading in from the directory that we specified above. And now let's just use the same data set here. So we're going to read this data set into our data frame. And now we're going to use this data frame with the pipe operator. And from it, we're going to be selecting only the a few variables. And then we're going to be reassigning them back as our data frame. So now we can easily get the structure of the data here, the structure of the data frame. Then we're going to be using Stargazer. This is the data frame, and we're going to be getting the summary statistics with that. And then we're going to get a table from this data frame. We're going to be selecting the year. So let's see what we get here. Um, so note that we have again loaded the data set here, and we have only selected and kept these few variables in the data frame. And now we're going to be using structure to summarize a structure for this data frame. So here's the data frame with 38 observations, 5 variables, and these are the variables that we have kept. So notice that these are exactly the same variables that we have selected up here. And we have 38 observations because we know that this is data by years. Basically, we have 38 years of data. So if we use Stargazer to get summary statistics, here again we have 38 observations, which are years. So again, this is kind of meaningless as far as average of the year. And these are the averages of the other variables in the data set, the standard deviation, and so on. So if we want to use a table to basically get the frequencies for the variable year from this data frame, we can see that these are the years for our data spanning from 1950 to 1987, and we basically have one observation per year, which makes sense with the time series data. Okay, so moving on, now we have pooled cross sections. So pooled cross sections is the same thing as when we have repeated cross-sectional data. So these are again not necessarily the same units repeated over time, but we have, say, 2 periods of data, but we have potentially different houses that are being sold in these 2 different periods. So here the example is to have pooled cross sections on housing prices. So here we have house prices for 2 years, and these houses are different in each year because not the same house gets sold in these 2 different years. So this is what what we call pooled cross sections. So again, different houses and in these 2 different periods. Um, and again, we have 2 periods. So we're again going to load the data set and keep only selected variables. We're going to be using house price, H price 3 data set. We're going to use the read.csv and assign it into our data frame here. And from this data frame, we're going to select these variables here, and we're going to be reassigning them back into the data frame. So we are going to be selecting year. This is a dummy variable. If year is equal to 81, the price of the house, the log price of the house, how many rooms and how many bathrooms the house has. So to summarize and describe the data, we're going to be using again the structure. To see the structure, of the data, stargazer to summarize, head of this is again the data frame to summarize the first 10 observations, and then we're going to summarize and get a frequency table from this data frame. We're going to be selecting the year. Okay, so let's see what the results in the console. So if we ask for the structure of our data frame, here we have 321 observations, 6 variables that we kept. These are the 6 variables that we kept. And these are the different variables that we have. So notice that the first few observations are 1978 as far as the year. This is the dummy variable if the year is 81. So obviously if we have this year, then it's a 0. And these are price, log price, number of rooms, and number of baths. Stargazer, we're going to be using this to get the summary statistics for our data frame. So here we have the number of observations and summarizing the mean and the standard deviations for the data. If we want to see the first 10 observations, we're going to use head. Here we have the data frame and the first 10 observations. These are the first 10 observations of the data. Again, we have pooled cross sections. So the first 10 observations happen to be for the year 1978, but we actually know that we also have the 81 year in the data set as well, as I will show you later on right here. So this is a dummy variable if the year is 81, which in this case is not 81, so we have a 0. And here we have the house price, log house price, number of rooms, number of bathrooms. If we use table to get a frequency table for a year off of this data frame, here we see that in 1978 we had 179 observations, and in 1981 we had 142 observations. So these are the number of houses that got sold in this year, and this is the number of houses that got sold in this year. Okay, so now we can also get summary statistics for price and year. So here we are going to be using this data frame. We're going to use the pipe operator here to pass it as the first argument here. So we're selecting from this data frame, we're going to select the price and the year, and then we want to summarize these variables with the stargazer. So here, using this data frame to select these variables and then summarize them. Here's what we're going to be seeing. So again, we're summarizing these two variables. The average price of the house is $96,100. And this is not a very meaningful average because it's summarizing the getting an average between these 2 years. Okay, so we can also get summary statistics for the selected sample. And so basically we can get summary statistics for the year before 1978. We want to see the average price before, and the after is the year 1981, and we want to see the average price in the year after. And so we're going to use exactly the same lines as here, except we're going to be filtering here if year is 1978. And so everything else is the same because we're saying from the data frame, filter if year is equal to 1978. Notice we use the double equal sign here. So we're going to be filtering and only keeping these observations. Then we're selecting the price, and then we're using Stargazer to summarize this. And so what this is showing us is this is the price. So the average $76,628. So notice here that the number of observations is lower, and this is actually summarizing only the house prices for the first year for 1978. And if you scroll back up, this is exactly the number of observations that we have in this frequency table here. And this is the number of observations for the next year. So again, we're seeing this right here. This is the number of observations here, and this is the number of observations in the second year. So these things kind of match up. So this is the average price for the house in the year before, which is 1978. And here, because we're filtering the next year, 1981, in the data, the second year in the data, this is the average house price in that year. So again, these are repeated cross sections. So we have two cross sections. One of them is for the year 1978, and the other one is for 1981. We can use summary statistics like that. But again, these are not necessarily the same houses that are being sold in these 2 years. Okay, so finally, we're going to talk about panel or longitudinal data. So this is panel data for wages of individuals across years. So here we have 8 years panel data of wages of individuals and other variables. So these are observations for the same individual for multiple years. So the person identifier here is NR. And then the time identifier here is year. So NR is a cross-sectional identifier and year is the time series identifier. So let's read the wage pen file, CSV file, from the directory that we specified above. We're going to use the read.csv um, uh, we're going to use read.csv and we're going to be assigning it into the WagePan data frame. So now from this WagePan data frame, we can select the variables that we're interested in. So here we would have the person ID, the year. This is our cross-sectional dimension. This is our time series dimension. And these are some of the variables that we're going to be summarizing: log wage, experience, education, and number of hours worked. Um, and then let's see the structure of the data. So this is the structure of the data. What we have here in our data frame, 4,360 observations. We have 6 variables that we selected and kept in the data here. And we can see the first few observations of each of these variables. And if we use Stargazer with the data frame type equals text, this is going to give us the table of summary statistics. So this is again the uh, person identifier. This is the year. And here are the variables that we have in the data set. And these are the means and standard deviations. And if we look at the data set, we can use head. This is the data frame. This is the first 10 observations. And here we would have first 10 observations. So here we have NR is the person identifier. So for person number 13, we see we have data for years 1980 through 1987. And this is their log wage. This is the number of years of experience, education, and hours. Notice how the number of years of experience very deterministically increases by 1 year in each subsequent year. And it so happened that this person did not get any extra education during uh, the the study here. And this is the total number of hours worked in a year. And here we have data for person number 17, and of course the data goes on and on. So kind of like a similar thing. So the final thing to do is we can get a table from the data frame for the variable year. And here we can see that we have these are the years that we have in the data set, and we have the same number of observations for each of these years, which means that we have a strongly balanced panel data set with equal number of observations for each year, or in other words, each person has the same number of years of data. Okay, so this concludes the introduction of different data sets and how to read those in R. Thanks for watching.